Hi there, welcome to this course. With this course, you learn and master some of the important microcontroller peripherals such as timers, Pwm Can Rtc, and low power features of the microcontroller. For this course, we have selected STM32 microcontroller. Now let me quickly introduce about our new classes in this course. In this course, you are going to learn advanced microcontroller programming and embedded systems concepts which help you to level up in your career. Let's see what this course covers for you. This course is fun and exciting and helps you to learn and master timers, CAN, RTC low power modes, STM32Cube framework with step-by-step guidance and code exercises throughout the course. This is a highly recommended course if you are seeking career in the domain of embedded systems programming. Now, the biggest takeaway from this course is gaining confidence and connecting the dots. I will assure you that once you complete this course, you will get enough confidence in handling any microcontroller you have at your hand by checking its reference manual, exploring the data sheet, and by the intuitive thinking. The intuitive thinking which you are going to gain in this course is really important because tomorrow you may not work on the same microcontroller at your office or in your organization. So at that time, you should be able to quickly adapt to new microcontroller environment because in this course, we try to understand peripherals from its register level by exploring its functional block diagram, and then we master the peripheral using code exercises. So confidence, that's the main takeaway from this course. So what if I don't like this course? Remember that if you don't like this course, then 100% refund is guaranteed by the Udemy. Asking a refund is just a click away and you will get your full amount refunded back to your account. So at the end of the day, you have got nothing to lose and everything to gain. So you can also reach out our Q&A team and fellow students for help, or if you have any questions or doubts via this online course discussion platform where thousands of students are already discussing about their questions and doubts, and you can also help other students. You also get course completion certificate once you complete course 100%, which you can proudly put on your resume. Please watch upcoming course overview video and read course description carefully to know more about this course. I hope I'll see you inside the course. Hey, welcome back to the lecture. So let's get started working with timers, and we will start with basic timers. Now, the basic timers have basic counting engine and they are majorly used for time-based generation. And these timers are very simple in nature. That's why they do not have input-output channels associated with them. So let's not worry about the input-output channels for a time being, and these timers do not have that. Now let's go further, and here is a timer assembly of STM32 basic timer. So you can also call it as block diagram. Now if you take a look into this block diagram, it is very simple. So here you can see that a counter place, this is a counting place, okay? Here the counting takes place and we call it as counter register. So this is actually of 16-bit, okay? So for basic timers, the count register or counter is of 16-bit. So this is a place where counting takes place, and here you can see that counting is powered by a clock that we call as count clock. So a counting speed is depending upon count clock. Alright, so this timer count clock is actually produced by this prescaler engine here, and you can see that there is an input clock to the prescaler engine, and that input clock is actually coming from here. That is the control block of the timer, and for the control block of the timer, another clock is coming here, that is the main timer clock. So for this engine, the main source of the clock is from the RCC engine that we call as reset and clock control. So you may be knowing this point from our earlier courses that the RCC block, that is reset and clock control block of the microcontroller, manages clocks to the various peripherals of the microcontroller. And it is also true that it manages clock for the timer peripheral also. So that's why timer clock is a clock which is the main clock supplied to the timer peripheral, that is here. And that is then processed by the control block of the timer peripheral, and that clock is then supplied to the prescaler. And here you can use the prescaler to slow down this clock. So you can slow down this clock in order to produce the timer count clock. And the counting speed of this counter depends upon this clock. And you can also find one important register. So please note this register. This is very, very important. That is called as ARR register. That is called as auto reload register. So whenever this counter reaches the value which is stored in this register, the counter resets back to 0 and it will start counting again. So in the previous diagram I have shown some threshold, isn't it? That is some pre-programmed value. So that value you have to store in the auto reload register. So when the counter value reaches this value, the counter rolls back to 0 and it generates an event called update event. And that update event has the potential to interrupt the processor. Now let's move to the next slide. Alright, so the time-based unit includes, the time-based unit means, so this whole thing is called as time-based unit. So this is a time-based unit of the basic timer. And the main parts of the time-based units are the up counter, so that is this one, the up counter, and the counter register, that is timer underscore count. Okay, so the X you can replace by any timer peripheral number, like timer 1 count register, timer 6 count register, like that. Okay, the counter register holds the value which is there in the counting engine, that is the up counter. That means this counter value which is actually accessed by the firmware by using the counter register. And then there is also something called as prescaler register, that is timer underscore PSC, and that is used to configure this prescaler engine. And after that we have very important register, auto reload register, that is also called as timer ARR, which is used to hold the reload value for the timer. So when the up counting value reaches the value which is stored in the auto reload register, the counter will rolls back to the 0 and it will start counting again. That's about the time-based unit of the basic timer. Now let's move forward. Alright, so now we have got the basic overview about the timer clock, the prescaler output clock, counter clock, the auto reload register, etc. But all these things you can only understand by doing one exercise. And these 4 parameters are really important in order to write a timer application successfully. So we'll understand all these things by doing one exercise. Now the exercise is very simple. Use the basic timer to generate an interrupt for every 100 milliseconds. And toggle the GPIO or LED inside the timer IRQ handler and verify using the logic analyzer. So we are going to understand so many things by doing this single exercise. So we are going to understand how to configure the basic timer, how to generate the desired delay, that is the time-based generation, and how to enable the timer interrupt, how to identify the timer IRQ number, how to implement the IRQ handler, and lots of other things we are going to understand by doing this exercise. Alright, from the next lecture onwards, let's try to complete this exercise. I'll see you in the next lecture.